Hello students, welcome to Sri Jayendra's Rank Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 7 of a unit electromagnetic induction. So let's begin. In today's session we are going to discuss first for the eddy currents. Now let's look what eddy current is. When we say eddy currents, then we understand that let's suppose if instead of a closed circuit, a metal plate or a disc either made to vibrate in a magnetic field, or we can say it has been placed in a variable magnetic field, then we understand that this will create an induced current are set up in it, and according to the Joule's law, this plate or disc gets heated. So what we are supposed to do is that this is the rigid support, and with this rigid support, with the help of, let's say, a string, this metal plate has been connected, and this metal plate is made to oscillate in this magnetic field. And let's say this magnetic field is fixed, or we can say it could be a variable magnetic field, but this is going to oscillate in this, something like this, from here to here and from here to here. When it is about to oscillate in this magnetic field, what we understand is that flux is changing, and if flux is changed in a closed circuit, a current is induced in it. Now the one of the question is how the flux is changing. If fixed magnetic field is there if fixed magnetic field is there, how the flux is changing. So remember, what is flux? We can say that it's a b dot a. When I say it's a b dot a, it is b a cos theta. So we need to change any of one, at least we need to change any of one at least to change the flux. Now which parameter it is changing in this case? Which parameter? I will say area is changing. How area is changing? Because let's say at certain portion of time this metallic frame would be here, and it is nowhere in the magnetic field. So here in this case, area within the magnetic field is 0. Now it is slowly inserting into the region having a magnetic field. So here magnetic field is increasing. At certain instant, at certain instant of time, it is completely in the magnetic field. So this is a max, and it is moving in this direction. Again now it is leaving the magnetic field. So at certain instant of time, again it's a equals to 0. So thus area is changing, and if area is changing, that means flux is changing. If flux is changing, EMF will induce. If EMF will induce current will develop in it. I hope this is clear. It says that, let's look at this. A flat conducting plate of aluminum or copper is oscillated through a magnetic field B, which acts perpendicular to the plane of the paper, and it is directed inward as shown in the figure. We have seen this. The direction of AD current is such that it compensates the increasing flux. Yes. What was the direction of induced current according to the Lenz law? We can say that it is it is flowing in such a way that it will oppose the one which will produce it. Yes. So here, which will produce it? It's a change in flux produce it. So what it is supposed to do is that it is going to stop that vibrations or stop that oscillation. So induced current should not flow. Now accordingly, when metal plate enters the field, the direction of the eddy currents are counterclockwise, it's an anti-clockwise. And because when it is going to enter, when this is, let's see, when this is going to enter the field, yes, this what the magnet flux is increasing. In this situation, flux is increasing. And if flux is increasing, what you need to do is you need to create a magnetic field. Such that it can decrease the magnetic field. How this will possible? Using the current in the anti-clockwise direction. So if current is in anti-clockwise direction, magnetic field due to this current will be the outside the plane of the paper. And if magnetic field is outside the plane of the paper, if magnetic field is outside the plane of the paper, this will decrease the flux. Same way, same way when it is leaving the field, the direction of the eddy current will be clockwise. It is something like this, that if you look at this, when this is leaving, when this is the leaving magnetic field, your area is decreasing. As your area is decreasing, your flux is decreasing. As your flux is decreasing, what you are supposed to do is you are just going to support it by increasing it. How to support it? By producing a magnetic field inside the plane of the paper. How magnetic field inside the plane of the paper can be formed? It's using eddy current in clockwise direction. I hope this is clear. So does this too clear? So this induced currents are called the eddy currents, or it's a Foucault's current. Foucault was the first. He was the first to study the current in it's at 1895. Yes, he was the first to study this eddy currents. The circulating currents set up in bulk pieces of metal moving through a magnetic field are called as the eddy currents. So, as the conducting plate enters the field, the eddy currents are the counterclockwise, and as the plate leaves the field, the currents are the clockwise. That we understand. So this current is what we call as the eddy currents. I hope this is clear. Is it clear? Now let's look at the some practical applications of the eddy currents. The damping effect of the eddy current has been put to use in the following. Yes, first it's a magnetic brake. Second, it's a deadbit galvanometer. And the third, we are using this eddy currents into the induction furnaces. Let's begin our discussion with the magnetic brakes. What it is and how does it work? We see that whenever a train is moving, its axle rotates and the drum attached with the axle also rotates. To stop the train, a magnetic field is applied on the rotating drum. Our drums are there. Axle is going to rotate as well as a drum is going to rotate. Let's suppose you need to apply a brake on the train. What you are supposed to do is you are going to apply a brake by turn on a switch on the magnetic field on the rotating drum. This due to eddy currents set up in the drum, an opposing couple acts on it, and when opposite couple acts on it, a train stops. Yes, so suppose if wheels are moving in this direction, then the opposing couple will act in this direction. Why? Because according to the principle of induced current, it will oppose the one which will produce it. Yes, so owing to eddy current set up in the drum, an opposing couple acts on it, and as a result of that, train will stop. This system is called as the magnetic brake. Since the eddy currents decreases steadily in magnitude as the train slows down, the braking effect is quite smooth. I hope this is clear. So we are using it. We are using this system in our train system while applying a brake. I hope this is clear. Does it? Now let's look at the second application. It's a deadbit galvanometer. The coils of moving coil galvanometer, ammeter and voltmeter are wound over the metal frames so that due to eddy currents the motion of this coil is damped, and the process is called as the electromagnetic damping. But in an ballistic galvanometer, to reduce the damping, the frames are made up of bad conductors. And why bad conductors? Because bad conductors are not allowed to flow a current, so no eddy current would be there. Or as in bad conductor, we can use a paper or we can use the bamboo as well. Yes, these are very bad conductors. They cannot, or they are not supposed to flow or conduct any currents within them. Next, let's look at the induction furnace. Next application, it's an application of induction furnace. If the resistance of a conductor is very small, current set up in it are very strong. Yes, if resistance is lower, current will be higher. It is as simple as that because V is the constant. This current produces a lot of heat in the conductor, and that is where we use an induction surface. It is based on the principle that and is used to prepare alloys by melting the constituent metals. Since the amount of heat, since the amount of heat produced due to eddy current is directly proportional to the square of its frequency, currents of higher frequency are used in this furnaces. So eddy current is developed which is directly proportional to the square of the frequency. So what we are supposed to do is we are going to use the higher frequency, and as we are going to use the higher frequency, the eddy currents will be higher. This is our requirement. This is the requirement when we use it in the induction furnaces. I hope this is clear. Is it clear? Great. Let's have certain quick questions. The circulating currents set up in bulk pieces of a metal moving through a magnetic field. What does it call? Yes, they have been called as the AD currents. Next, blank is an example. Blank is an example for AD currents. Yes, it's in we are using it into the induction furnaces. We are using it into the deadbed galvanometer. We are using it in the magnetic brakes. So this all are the applications of the eddy currents. I hope this is clear. Is it clear? Is it any doubts? Is there anything? Is there anything? Anything? No? Great. Now let's discuss that how to reduce eddy current, because that is something that creates a loss in energy. So if you want that my eddy current should be reduced, how you will reduce it? What are the options? Any idea? Is there anything? Look, this is the rectangular or square plate I am using as a pendulum. Now what I can do is that I can make this plates as a slotted plate. Let's suppose something like this, that I am using these slotted plates, that by the use of slotted plates you are reducing the path of AD currents, and thus AD currents can be reduced. Yes, so only this slots can be there, and the slots will not provide a conducting path to the eddy current, and thus we can reduce the eddy current. I hope this is clear. Is it clear? Is it? Are you sure? Great. Now let's discuss the AC generator. What is generator? A generator is a device which converts mechanical energy into electrical energy, that we call as an AC generator, or even it is called as a dynamo. It's an AC dynamo. It works on the principle of electromagnetic induction. When we understand the generator, we discuss about the three main parts in the AC generator. They are the first, armature, the rectangular coil. Second, it's a field magnet, slip rings, and carbon brushes. So these are the main parts. These are the main parts of AC generator. I'm sure that you even have studied this AC generator in your class 10 as well. But Here we will discuss a certain parameter in more advanced version compared to the class 10. So let's look. This is the magnets. Generally the horseshoe magnet are used. That horseshoe magnet can provide a uniform magnetic field throughout that region. That's why generally that has been preferred. An AC generator consists of a coil. This is the coil. This is the coil that rotates mechanically on shaft between two poles of a horseshoe magnet by some external means. So what we are supposed to do is from here we are doing certain arrangement such that that can rotate this rectangular coil. Now which arrangements are possible? We have different power plants. When I say different power plants, let's say we have a hydropower plants, we have a nuclear power plant, we have the mechanism that we can flow the steam, and that steam will be strike to the turbines and it can rotate. So we have a different mechanism externally that can rotate this coil, and the ends of this coil are connected to an internal circuit by means of the slip rings and brushes. These are the slip rings. This you can see, this and this are the slip rings, and slip rings are connected with the brushes. Brushes are generally made up from the carbon, and that is used to set up a connection. And the slip rings are there which is being connected with this rectangular coil. You can see the connection. So I understand that as the coil rotates, the flux passing through it changes. What we are supposed to do is we are going to rotate this coil, and once we are going to rotate the coil, my flux changes. Now the question is, what is changing in flux? That theta is going to be changed. That's, we can say, orientation. Theta is changing, and as I say, the theta, it's an orientation between B and A is changing. Flux is changing, EMF is developing. That is what our requirement is. Now by Fleming's right hand rule, the direction of the current through the coil changes in each half cycle of its motion. Let's understood that phi b is the magnetic flux. That is linked with the coil at any instant, that we call phi b is equals to nba cos theta. It is something like this. It's a phi is equals to nba cos theta. Now we have this relation omega is equals to theta by t, and if I replace this, then theta could be written as omega into t. So this flux could be considered as an nba cos omega t. Now from Faraday's law, the induced EMF at any instant can be considered as E is equals to minus of d phi by dt. This would be minus of d by dt of nba cos omega t. If I differentiate this, nba would be the one that is not going to be differentiated. It's a constant quantity. And cos omega t, if I differentiate cos omega t, it will be a sine omega t multiplied by omega by the chain rule. I hope you understand. Yes. So this emf is time dependent because it's a sinusoidal wave. Sine and cos are called as the sinusoidal wave. When I look for the maximum emf, it would be equals to omega into n into b into a. This is the E max sine omega t. Now that I understand that sine omega, range of the sine omega is from +1 to -1, and sine omega t, this is having a value of +1 when it is an angle of 90 degree, pi by 2, and minus of 1 when it is at a 270 degree, which is 3 pi by 2. So this will give a maximum value at pi by 2 and 3 pi by 2. The instantaneous value of the EMF E, that can varies between the plus Emax and minus Emax, that is periodically. It is something like this. In the next unit we are going to observe this is something like this. This is plus Emax, this is minus of Emax. This is varying sinusoidally. Hence the EMF induced in the coil of the generator is sinusoidal alteration. I hope this is clear, and this is how generator works. Yes. That requirement of our generator is to convert mechanical energy to electrical energy. This sinusoidal and this EMF is developed, and when this kind of EMF is developed, we can say that that we are having the system that can convert mechanical energy to electrical energy. Is it clear? Is it clear? Are you sure? Do you have any doubts? Do you have any doubts? Is there anything? Is there? No? Great. Let's find out the quick questions. A device which converts mechanical energy into blank is called AC generator. Yes, mechanical energy to electrical energy. Next, sine omega t lies between plus 1 and minus 1 at an angle of 1. Sine omega t plus 1 when it is at 90 degree. 180 degree, no. Sine 180 is 0. Sine 180 degree, it is 0. Sine 270 degree, yes, it's a minus 1. So this two are correct, so answer would be this. It's both A and C. I hope this is clear. Does it clear? Does it clear? Are you sure? Are you sure? Great. Let's work for one of the numerical. Let's have a look. The question says that a rectangular coil of 50 turns rotates uniformly with an angular speed of 240 rpm in uniform magnetic field. Find out maximum EMF induced in the coil if magnetic field is of 10 Tesla and cross sectional area of coil is 50 centimeter square. So go through the data, what all they have given, and let me know how will you do this. So what all they have given, that a rectangular coil is having a 50 turns. So N is given, it's a 50 turns that has been rotating in uniformly with an angular speed of 240 rpm. So even omega is given, that is a 240 rpm. It's a revolutions per minute. Let's convert this to 2 pi by 60. It's an 8 pi radian per second. Now it is ready to use. In uniform magnetic field, find out maximum EMF induced in the coil if magnetic field B is given. It is of 10 Tesla, and cross sectional area of the coil A is given, it's a 50 centimeter square. So it's a 50 into 10 to the power minus of 4 meter square. Now what I want maximum EMF. So let's, it's an E max will be equals to N B A omega. N is the number of turns, it's a 50 number of turns. Magnetic field, it's a 10 Tesla. Cross sectional area, it's a 50 divided by 10 to the power 4 into omega, it's an 8 pi radian per second. So this 3 has gone and this has gone. So this is equals to 5 is are 25 8s are 200 pi divided by 10, which should be is equals to 20 into pi volt. This is the Emax. This is 20 into pi volt. This is the maximum EMF developed in the coil. I hope this is clear. Is it clear? Is it any doubts? Is there anything? Any doubts? Are you sure? Are you sure? Correct. Let's discuss about the motors. Now, what motor is? Basic principle of motor. This it is used to convert electrical energy to mechanical energy. So this is the basic principle behind any motor, that even you have studied this in class 10 as well, that motor will convert electrical energy to mechanical energy, while we have already seen the generator which is used to convert mechanical energy to electrical energy. So both are the units that do vice versa kind of thing. Let's look at the motors and the diagram, or the we can say it's a basic structure of a motor. So let's understand that this is the north pole, this is the south pole, and this north and south pole we have kept one of the rectangular coil. This rectangular coil is A, B, C, D, and that has been placed, and all the remaining apparatus are the same, that we have a carbon brushes over here, we have a slip rings over here, we are having an armature over here that we call as the rotor of the motor, and stator, that stator is the part which remains the steady in the situation. Now let's quickly discuss about the working principle of the motor. You can see this has been connected with battery or a cell. Let's call EMF E or the potential V. Now the current will pass through here, current will pass through here. So from this part to this, in this direction current will be going. Now one more thing is that here north pole of a magnet is there, here south pole of magnet is there. So there must be a magnetic field in this direction. So if you understand the thing very seriously, that in this situation it's a rectangular coil, and from this it's an A to B. You can look at something like this, that this is A to B. Yes, and in this direction a magnetic field is there. This is the wire A to B, and this is the region of the magnetic field. So if you understand that a wire could be there which is having a flow of current is there, it is placed in the uniform magnetic field, one of the force must be acting on this. Let's call this it's an F1, and that F1 could be written as it's a IBL into sine of theta. I hope this is clear. Yes. So if I use left hand rule, if I use Fleming's left hand rule, I can understand that force on the A to B section, a force on the A to B section is that magnetic field is in this side, and current is moving in from A to B. So in this A to B, magnetic field is acting inside the plane. This is the direction of force 1. Same way, if you use right hand, if you use a right hand, then you must understand that even on this side magnetic force is acting, and this force is acting on this. So this is F1 is equals to IBL sine theta. On the second part it's an F2, that is equals to again IBL sine theta. In both the cases this force is, this theta is 90. So F net would be there, as you can understand that this is the situation, that if I draw the simply diagram, it is something like this. On this segment it's an A B C D. Let's see that on this situation force is acting in downward direction, on this situation force is acting in upward direction, and it has been, let's call this the axis of the ring. So this will start rotating, and once it is starts rotating, what I understood is that this could be given as this F net would be equals to, would it's a BIL sine theta plus BIL sine theta. Yes, this is 2BIL sine theta kind of thing, or I should say it's a torque would be available, and that torque would be equals to M cross B. It's what we call as an MB sine theta, which was the requirement. What we are requiring, we are here to convert electrical energy to mechanical energy. Yes, and that could be done. It's a torque that could be written as M cross B. This is equals to MB sine theta, that we have discussed up till now, even in this situation of the normal motor. Now now the problem is that, let's understand that in this region a magnetic field is there. A magnetic field is there, and you have put your rectangular coil in this uniform magnetic field that has been provided by the horseshoe. So as this coil, let's suppose something like this, as this coil starts rotating with omega, it is going to disturb the magnetic flux. And once it is going to disturb the magnetic flux, we understand that phi is equals to B dot A. This could be given as BA cos theta. If I replace this omega with the theta by T, yes, so it's a B into A into cos of omega T. Let's work for the magnitude only. This is E is equals to d phi by dt, and this could be given as d by dt of, it's an B into A into cos of omega t. Here I'm talking about the number of turns equals to 1. So this is equals to, it's a B into A. Cos omega t could be given me the minus of sine omega t, but I need to apply a chain rule to this, will give me the omega. So this EMF could be written as, I'm talking about the magnitude of this, it's a omega into B into A into sine omega t. This is what I am talking about for n equals to 1. But this rectangular coil if this rectangular coil contains n number of turns, then this EMF could be written as NB A omega sine omega t. It is absolutely okay up till now. We don't have any issue with this, that this was E is equals to NB A omega sine omega t. This is the EMF induced. This is the EMF induced in this coil. And as you understood that, according to the, if EMF is induced in turn of this, according to the Lenz's law, according to the Lenz's law, induced current is developed, which will oppose the one, which will produce it. I hope this is clear. So the thing is, and the real situation is something like this, that you have provided an EMF to your circuit, and due to this EMF, this was the situation. Now you might got an idea that about which problem I am talking and why I am worrying for this. I was not having any worried for the motor. The thing is, I am worried that as it is disturbing the flux, this will create an induced EMF, and this induced EMF will develop an induced current which will oppose my motion. So this is the problem. So as this was the situation, this is the magnetic field, and if it is working up till now, we don't have any issue. But now the situation worsen, as this induced EMF is known as the back EMF, as the back EMF. This is going to oppose the motion. So let's understood that this is this current through this could be written as I is equals to E minus E divided by RA, while E is the supply voltage that you have provided from this is E, it's a supply voltage. This E is the back EMF, and RA, it's a armature resistance. This is armature resistance. So this is the situation that whatever the current I was expecting at initial, that let's suppose EMF is there, let's understood this all are the calculation for the understanding purpose only. Let's suppose that this EMF is, let's say, 100 volt, armature resistance, let's say 10 ohm, then you might expecting that current of 10 ampere must pass through this. It's a 100 by 10, it would be a 10 ampere. But as you are going to observe this at this point of time, that once it has been started, this current starts varying. Now you wonder that why this is varying, because my EMF is fixed. Yes, it's an 100 volt. My resistance is fixed, resistance of armature. It's an armature is this rectangular coil. Let's call this, it's an A, B, C, D. So I'm sorry. So resistance of this armature is fixed, battery cell is fixed. How this current is varying? When I got surprised, I understood that this is the back EMF which changes, and this creates a problem. Now why this creates a problem? Let's think this a certain logically. Let's have a look. Whatever the current now I am going to receive is the E minus E divided by RA. What is E? We call this as a back EMF. What is E? This is something like this. It's a NBA omega cos omega t. That is what we understand. Now the problem is this is fixed. We don't have any issue with this. The problem is this is with respect to time, which is changing. So it means as soon as time passes, that means speed of motor increases. Yes, as this is changing, this omega is increasing. If omega increases, that means back EMF increases. This is back EMF increases, and as back EMF increases, which in turn reduce the current, through armature. I hope this is clear. And if this current is reduced, that will affect on the omega, and it will probably at one instant of time it is going to stop rotating, and whole the functioning of motor will be collapsed. I hope this is clear. So what is situation of this? What is situation of this? Let's suppose you must understand this, that let's suppose a requirement of current in armature is, let's say, 10 ampere. So initially what you have done is requirement of current in armature that according to you was 10 ampere. So what you have did is that you visit the market, take a cell of 100 volt, take a resistance, that is the armature resistance, that means you have taken one of the wire, convert it to the rectangular coil, and you make sure that its a resistance would be the 10 ohm. So what you understand, what I is equals to E by RA. This is I am talking about the external EMF. Yes, and that was 10 ampere according to you. But as motor starts, as motor starts, starts developing it starts developing back EMF. I hope this is clear. Do you understand it? Let's understand that back EMF maximum back EMF, it's, let's suppose, a 10 volt. This is at maximum speed omega. At maximum speed omega. So now the situation will be, you were expecting this current, and what you are getting is, this is equals to 100 volt minus 10 volt divide by armature resistance. This is 10, which should be is equals to 9 ampere. So your requirement is this 10 ampere. You are getting this 9 ampere. So your performance will be deproved. Your performance will decrease, and this motor will no longer work for you in an effective manner. So what should you do? What do you think, that how could I resolve this issue? So probably you might get an idea that, sir, what is the problem in this? As we have purchased a battery, or we have purchased a cell of 110 volt, and you said that maximum back EMF is 10 volt. Maximum back EMF is 10 volt. Let's purchase this of 110 volt. So let's work according to your solution, that new purchase of the E dash would be equals to 110 volt. My armature resistance, it is of 10 volt, 10 ohm, sorry, and I understood that E max, it's a maximum back EMF, that would be equals to 10 volt. So according to you, the situation is that I is equals to E minus E divided by RA. This is equals to 110 minus 10 divided by 10. This is equals to 100 by 10. It's a 10 ampere. According to you, this will work. But dear, let me understood one thing, that this is the maximum back EMF. This EMF, this E max will be 10. Give me a moment. Yes, this E max will be at 10 volt when motor rotates at maximum speed. That means observe your fan, that once you switch on the fan, it starts rotating with minimum omega. Then it keeps on changing its speed. Basically it works on the motor only. So motor works like that, that when you switch on it, it cannot come to the maximum speed in no time. Initially it is rotating with certain low speed. Let's call it, for understanding, it's a 5 rpm, 6 rpm, 10 rpm, increasing 20 rpm, 30 rpm, 40 rpm, and let's say 100 rpm. So if I suppose that my motor reaches to a maximum of 100 rpm, it takes a certain finite amount of time to reach it. So initially if I took it initially, that means at t is equals to 0, where motor has just started, I can understand that back EMF is 0. And if it is 0, this I dash would be is equals to E by RA. And this E, that means this E dash is 110 divided by 10, which is equals to 11 ampere. So the problem is, this is, your armature can pass maximum 10 ampere of current through it. Now in this situation, your armature is going to pass 11 ampere, as it exceeds maximum current. It exceeds maximum current, it will burn out. It will burn out your motor. Do you understand the seriousness of this? Have you? So as your maximum requirement is 10 ampere, what you are passing through it at t is equals to 0, 11 ampere. So it at t is equals to 0, it is going to die out. So you will be not having a time that, sir, at one point of time my motor will be rotating at 100 rpm, and that point of time the current will be 10 ampere. That is absolutely okay. But the thing is, your motor is going to die out at t is equals to 0 second, and you don't have the time to do this. I hope this is clear. Is it clear? Why this problem arises? Because this back EMF is keeps on changing. Why changing? Because this omega is changing. Why omega is changing? Because its speed is changing. As omega is changing, back EMF is changing. As the time passes, this EMF E will increases. I hope this is clear. So now what is the solution of this? We understood the problem well, that this problem arises. How this problem arises. Do you understood this completely? Do you understood this? So what I understand is that let's understood a certain logical parameter, that I is equals to E minus E by RA. Initially, let's understood that this is the situation, that I is equals to E minus E by RA. At t is equals to 0, at t is equals to 0, E is equals to 0, and that's why I is increasing. So at t is equals to 0, what I want is that resistance should be higher, and let's say at t is equals to t, when omega is maximum, let's say when t is equals to t, omega is maximum, at that time back EMF is maximum. So if at this point of time, if I decrease the resistance, its a resistance should be minimum. In this situation or in this manner, I can save my motor, then I will prevent it to die out. So what I basically require is it's basically a variable resistance. It's a variable resistor is required to be connected in connection with a motor, so that it can save my motor dying out. So this variable resistor is the starter of the motor. This is what we call as a starter. It works something like this, that this is the motor, this is just the electromagnet, and this is the handle, and this is the spring. What initially happens is, let's understood that this is 10 ohm, this is of 10 ohm, this is of 10 ohm, this is of 10 ohm. Initially your handle has been connected to this point. Let's call this point as an H. So initially this all resistance 10 10 10 10 at t is equals to 0, resistance of this starter is 40 ohm, and at this instant you are providing a maximum possible resistance to your motor, which is your requirement, which is your exact requirement. You want that at t is equals to 0, my resistance requirement would be the maximum. Now as the motor starts, omega increases, back EMF increases. What you are supposed to do is, you are going to throw this hand on over here. So now at this point of time, your resistance will be only 10 plus 10 plus 10. One more time will passes, some more time, and you are going to throw your hand over here. Now it's only 20 resistance, 20 ohm of resistance. One more time will pass and you will throw your arm over here. So this is at t is equals to t, your resistance will be equals to 10 ohm only, and this is the R minimum we are talking about, and your motor has been saved. So this is how starter works. I hope this is clear. Is it clear? Is it clear? So this is how we combine a motor and starter, so that a back EMF cannot burn out. A back EMF cannot burn out the motors. I hope this is clear. Is it clear? Any doubts up till now? Is there anything? Is there? No? Great. Now let's discuss about the efficiency of motor. When I said it's an efficiency, this is efficiency would be always equals to the it's an output power divide by input power. So let's discuss if it is in percentage multiplied by 100. Yes. So let's discuss what is input power and what is output power and everything. So we understand that power input to the motor is the supply multiplied by current. This P we call it as an E into I. The when this heat loss would be there, and this heat loss could be considered as, let's say, I square R. So according to this, whatever I am going to get as an output, whatever the I am going to get as an output is the, it's an EI minus of I square R. It's a EI minus of I square R. That could be written as the E into I. This E is the back EMF, and now you understand very well what back EMF can do. So let's find it out. The efficiency, this would be equals to power output divide by power input multiplied by 100. So this is EI divide by E into I multiplied by 100. So this is E by E multiplied by 100. Please do remember this formula. Please do remember this. This is very helpful to us. I hope this is clear. Now one more thing, even this can be asked something like this N is equals to, this is equals to EI minus of I square R divide by EI. I hope this is clear. Is it clear? Is it? Again multiplied by 100. So from this a certain questions can be asked based on the formula based questions can be asked. Let's have a look one of the question. That question says that if motor has been supplied, if motor has been supplied with EMF of, let's say, 100 volt and back EMF, or I should say maximum back EMF of motor is 90 volt. Find out efficiency of this motor. So when I say it's an efficiency, it's just like efficiency is equals to E by E multiplied by 100. Back EMF, or I should say maximum back EMF, it's a 90. I have been supplied with the 100 volt multiplied by 100. So this has gone, this has gone, this has gone, this has gone. It's a 9 tens, a 90 percentage. This could be the efficiency of your motor. I hope this is clear. So do you understand this? Do you understand this completely? Great. Let's just wind it up this session over here. This was a very informative session about the, we have begin with the AD currents, then we have switched to the generator, and at last we have discussed the motors. This all are the very small segments and small concepts, but they have certain questions with themselves. So please do this understood. Please understood this. This is very important theoretical aspect which can be asked in our competitive examinations, which are having a track record to be asked. Please understood this. Please go through this. Have a question practice based on this. This will help us. Thank you. Have a good day. Take care. Bye bye.